Hello everyone, welcome to the YouTube channel of YourPedia Engineering Career Point. So I am Vinny Sharma, your mentor of mechanical engineering. So I am here to provide you the previous year solutions of the BDL Management Trainee exam. Okay, so I am going to cover the 2023 exams or 2023 exam paper of the BDL here. So before wasting any time, let us continue with the solutions here. So in this question paper, I am going to provide you this answer key also. Okay, and that answer key is basically mentioned by the BDL recruitment exam. Okay, agency here. So now see here the first question of the exam is the intensity of the radiation from a black body is defined on the basis of its projected area and is dash of the direction of emission. So see here basically the first question is related from the heat transfer. Okay, in that case it is specifically asking you about the intensity. Okay, so the intensity topic is basically covered from the radiation part here. Okay, which is defined with the help of Lambert cosine law. Okay, it is defined on the basis of Lambert cosine law here. So this question is directly based on that Lambert cosine law here. Okay, so according to the Lambert cosine law, the intensity is basically independent of the direction of emission here. Okay, why so I can say that? Because if you see in the case of a black body, if we talk about the black body emits the radiations uniformly all over the all direction. In all the direction it uniformly emits the radiation and it doesn't depend upon the particular emission angle here. Okay, so that is why we can say the intensity of radiation is defined on its projected area and is independent of the direction of the emission here. So option number D is going to be the correct answer. Just make sure this answer is given by the recruitment agency here. Okay, next part is the Kaplan turbine. See, whenever we study the fluid machinery part, there we cover the different types of turbine. Okay, where we classify the turbine on the basis of the type of energy at the inlet of the turbine here. Okay, and we have a impulse turbine as well as the Kaplan impulse turbine as well as the reaction turbine here. So in the case of impulse turbine, we have only kinetic energy at the inlet, and when we talk about the reaction turbine, we have kinetic energy as well as the pressure energy. Okay, and the reaction turbine is further classified into a number of ways, like we have a Francis turbine, we have a propeller turbine, we have a Kaplan turbine, we have a Fournier turbine. In all of those turbines, we have both pressure energy as the kinetic energy, both as well as the pressure energy as well as the kinetic energy. Okay, and the basic difference is between the direction of flow. So when we talk about the Francis turbine here, in that case the flow is taking place in the radial direction here. Okay, but when we talk about the Kaplan turbine, in this case the flow is taking place axially here. Okay, so that means the flow is taking place parallel to the axis of rotation in the axial flow direction here. Okay, and along with that the propeller turbine is also an axial flow turbine. The basic difference between the Kaplan and the propeller is that in the case of Kaplan turbine the blades are adjustable, whereas in the case of propeller turbine the blades are fixed to the shaft here. Okay, next part, a vibrating system influenced by any external resistance to its motion typically undergoes. Okay, so now just see, this question is related to the theory of machine. So in this case, whenever we are covering the fluid vibration part, there we consider the two types of problems here. We deals with the free vibrations or we deals with the damped system there. So undamped system is basically can be studied under the free vibration part, which is also known as the natural vibrations here. Okay, here I am not assuming that the force is acting on the system here. There is no force acting on the system here. Okay, the force is only applied at the initial time, at the initial state, in order to disturb the system here. And the second one is the damped system. In the case of a damped system, we have a damper which absorb the energy here. Okay, or I can say the energy of a vibrating system continuously loses in the form of friction here. So here you can see the vibrating system is influenced by an external resistance. So that means the friction is opposing the motion here. So we can say it is a damped vibration case. So option number C is going to be the correct answer in this case. Next part, a Bernoulli equation, the term rho v square by 2 stands for. Okay, so now just see, this term is very similar to the kinetic energy. The kinetic energy is given to you as half mv square. Okay, and if I just divide this kinetic energy with the volume here, so here you can see the mass upon volume is represented as density here. So we can say the kinetic energy per unit volume is given by half rho v square here. Okay, so the option number C is going to be the correct answer here. Next part here, when for every speed within the working range there is only one radius of rotation. When for every speed within the working range we have only one radius of rotation, the governor balls at which the governor is in equilibrium, the governor is said to be. So now just see, in this case Basically here we are dealing with the stable governor here. Why we can say that we are dealing with the stable governor? Because in the case of a stable governor, you will observe that for every speed within the working range, within the working range, we have only one radius of rotation here. Okay, and whenever, let us say, if there is a very large amount of fluctuation due to the some little bit amount of change in velocity, we can say the governor is said to be hunting here, in the hunting state here. Okay, so in this case you can see the stability basically ensure that the governor provide the consistent performance over the whole range of the speeds here. Okay, so here we can say the option number A is basically the correct one here. Okay, the governor is basically stable here in this case. Next part, the point on the phase diagram at which the substance becomes indistinguishable between the liquid and gaseous state. So here you can see, here you have to simply draw the TS diagram. So if you draw the simple TS diagram, temperature entropy diagram of a pure substance, in which you are showing the liquid plus vapor region as well as the vapor region. So there we have a point at this state, and this point is known as the critical point. Okay, so we can say above the critical point the liquid is directly flashing into the corresponding vapor state. Okay, and it will become very difficult to distinguish the liquid with the gaseous phase here. So that means the critical point, the option number B, is going to be the correct answer of this question here. Okay, next part, the damping factor is the ratio between the damping coefficient and the. Okay, so now just see, in the case of a damped vibration, basically damped vibration, the differential equation of the system is represented by this term here, mx double dot plus cx dot plus sx equal to 0. Okay, so here this C is known as the damping coefficient here. Okay, and this C, okay, and just see one more thing, we can also write this equation in this form also, x double dot plus 2 zeta omega n x dot plus omega n square into x equal to 0 here. So here you can see this zeta is known as the damping coefficient, damping factor here. Okay, it is also known as the damping factor, or it is also known as the damping ratio. So if you define the damping factor or damping ratio, it is defined as the ratio of the damping coefficient to the critical damping coefficient. Critical damping coefficient means when the value of the zeta is equal to 1, the corresponding value of damping coefficient is known as the critical damping coefficient here. Okay, and on the basis of the zeta, on the basis of the values of the zeta, we define the different vibration system. So when the value of the zeta is greater than 1, we say it as a over damped system here, and when the value of zeta is equal to 1, it is known as the critically damped system here. Okay, and same way, when the value of zeta is less than 1, the system is known as the under damped system here. Okay, always remember this one part here. So here you can see the damping factor is the ratio between the damping coefficient and the critical damping coefficient here. Option number B is going to be the correct answer here in this case. The next part is, which of the following implies that the energy can be converted from one form of energy, one form into the to the another with the interaction of heat, work and internal energy, but it cannot be created nor destroyed. So here you can see this statement is dealing with the conservation of the energy here. Okay, and if we talk about the law of thermodynamics, the first law of thermodynamics deals with the conservation of energy. Okay, which is defined for a cycle in this way: the net heat transfer to the cycle is basically equal to the net work interaction from the cycle here. Okay, so we can say for a cycle, you can write the first law of thermodynamics as net heat transfer is equal to net work transfer here. Okay, and when we talk about the process here, the first law of thermodynamics is written as Q is equal to delta U plus delta W here. Okay, so here you can say the option number A is going to be the correct answer in this case. Next part, the value of the NTU. The value of NTU, the closer the heat exchanger approaches its thermodynamic limit here. Okay, so now just see what is the meaning of NTU here. NTU is basically representing the number of transfer unit. Okay, it tells you about the overall size of the heat exchangers. Okay, and we can say if you have the basic idea of the effectiveness of the heat exchanger. So basically the effectiveness of the heat exchanger is defined as the function of the NTU as well as the heat capacity ratio here, that is C also. Okay, so we can say higher the value of the NTU, the corresponding efficiency of the heat exchanger is going to be maximum, okay, or it is going to be improved. So here you can see if you are continuously increasing the value of the NTU, the corresponding effectiveness of the heat exchanger is basically improving, or we can say the heat exchanger is approaching it toward its thermodynamics limit here. Okay, so here the option number D is going to be the correct answer here. That's a very simple question actually, but you have to be able to understand that how the NTU and the effectiveness parameters are related to each other here. Next part. For regenerators, C minimum and C max is equal to, where C minimum is the minimum fluid capacity. Minimum fluid capacity means the mass, the product of the mass flow rate of cold fluid multiplied by the specific heat of the cold fluid. Okay, I am not sure that whether the cold fluid is having the low value of the heat capacity or whether the hot fluid is having the low value of heat capacity. Here, if I assume that the cold fluid is having the value of the cold fluid is having the low value of the heat capacity, in that case, the MC CPC is going to be less than the MHCPH. Okay, that you have to remember. So now just see, it is asking you to define the relationship between these two parameters for the case of regenerator. Now, what is the meaning of regenerator type of heat exchanger? See, heat exchanger is basically a device which is used to exchange the heat from one fluid into the another fluid. Okay. So here we have a different type of heat exchanger, like we have a direct contact type, we have a recuperative type, we have a regenerative types. So basically in the case of regenerative types, you have a third material which is known as the matrix. So first of all, what are you doing here? You are basically flowing the hot fluid over the matrix. Okay, and the hot fluid is basically transferring its heat to the matrix here, and the matrix is storing the heat. And after the flow of hot fluid, what we are doing? We are flowing the cold fluid here over the matrix here. Okay, so in this case, basically, in the case of regenerator, the value of the specific heat ratio, the values of the heat capacity ratio, it can be anything. Okay, it depends upon the heat capacities of the hot fluid and the cold fluid here. So we can say its value can be greater than 1, it can be equal to 1, or it can be less than 1. Okay, so if you just compare the option here, the option number D is going to be the correct one. That none of the option is basically correct here, but the recruitment agency has given you the option number A, so it can be objectionable question here. Next part. For two helical spring connected in series, the equivalent stiffness K of the assembly is given by. That's a very simple question. We already know that when the springs are connected in series, in that case, the equivalent stiffness is calculated by 1 by K is equal to 1 by K1 plus 1 by K2 here. That's a very simple part. Okay, how can you say that? Because here the springs are connected in series. So let us say if you have a simple spring and two springs connected in series, and both the springs are having the stiffness as K1 and K2, and if you apply the weight here, what will happen? The same amount of force is going to be exerted in both the cases here. Okay, so here you can see F is going to be equal to F1 is equal to F2 here, and we can say the corresponding total deflection of the mass is going to be equal to deflection of spring number 1 plus deflection of spring number 2. So we can say the force upon the total stiffness, or I can say the equivalent stiffness, is going to be equal to F1 by K1 here plus F2 by K2 here. So you can simply cancel out the force here, and you will get the expression as equivalent stiffness is going to be 1 by K1 plus 1 by K2 here. Okay, so the option number B is going to be the correct answer in this case. Next part. The value of the universal gas constant in joule per Kelvin. That's a very direct question here. The value of the universal gas constant is basically equal to 8.314 joule per Kelvin per mole here. Okay, just remember this one part here. Okay, and if you calculate the value of the characteristic gas constant, the value of the characteristic gas constant can be calculated by taking the ratio of universal gas constant divided by molecular weight here. Okay, this value is going to be different for all the gases here, but the value of the universal gas constant is going to be remain same for all the gases here. So here the option number C is going to be the correct one. Next part. If the Reynolds number is 4200, the fluid flow can be characterized as, that's a very simple case. If the value of Reynolds number is less than 2000 or 2300, we can say it is a laminar flow. Okay. And similarly, when the value of Reynolds number lies between 2300 and 4000, the flow is in the transition phase here. And when the value of the Reynolds number is more than 4000, here we can say the flow is turbulent here. Okay, so here the option number A is going to be the correct answer here. Okay, because the value of the Reynolds number is more than the 4000 here. Next part, for two helical springs acting in parallel, the equivalent stiffness of the assembly. Again, always remember, whenever the springs are connected in series, in that case the equivalent stiffness can be calculated by this formula, but here it is connected in parallel, so the formula is going to be equal to, option number C here. K is going to be equal to K1 plus K2 here. Okay, always remember this one. So option number C is going to be the correct one in this case. Next part, the equilibrium speed of an isochronous governor dash for all the radius of rotation of the ball within the working range neglecting friction. Okay, so always remember, so whenever there is a change in radius of rotation, the isochronous governor is going to have a same velocity here, same speed here. Okay, so option number C is going to be the correct answer here. And when I ask you that what will be the sensitivity of the isochronous governor, the sensitivity of the isochronous governor is infinite, whereas if we talk about the stability of the governor, then it will be equal to 0 here. Okay, and also remember, the Porter governor or Watt governor, they can never be equal to, they can never become the isochronous here. Okay, it is impossible to make them isochronous here. Why so? Because they have a particular value of a arm here for every speed of a rotation here, and correspondingly, let us say if we talk about the Wilson-Hartnell governor here, or a spin control governor, they can be made as a isochronism. The required condition is that mg plus fs1 divided by mg plus fs2. Okay, it should be equal to the ratio of R1 by R2 here. So if this condition is satisfied, at that point of time we can say the spring control governor or a Hartnell governor can be made equal to isochronous governor, but the Watt and Porter governor, you can never make it as a isochronous governor here. Next part, which of the following is an example of Newtonian fluid? See, the Newtonian fluids are those fluid which follows the Newton law of viscosity. So the Newton law of viscosity is given by tau is equal to mu du by dy here. Okay, so here you can see, in this case the viscosity is basically constant and it is depending only upon the time here. So it is basically a function of temperature here. Okay, it is not depending upon the velocity gradient and it is not depending upon the time here. So in this case, out of these four options, the option number C is representing the example of a Newtonian fluid. Other examples are air. Okay, we have a kerosene. Okay, these are the example of a Newtonian fluid here, and these are also considered as a real fluids. Next part, the surface that completely absorb all the incident radiation is called a, that's a very simple question. Here we have a black body here. Okay, black body is considered as a perfect emitter. Okay, it absorbs all the radiation which is incident on the black body, and it is also emitting the maximum amount of radiation here. Okay, at a particular temperature. Next point, surface tension has a dimension formula. See, the surface tension is defined as the force per unit length here. Okay, and the unit of the force is mlt minus 2 divided by length here. So here you can see the dimensional formula of the surface tension is mt minus 2. So here the option number C is going to be the correct answer here. The next part, Kirchhoff law states that for all the bodies at thermodynamic equilibrium, the ratio of the emissivity to absorptivity. That's a very simple question. Actually, the Kirchhoff law, which you covered in the radiation part of the heat transfer, it states that whenever the two bodies are in thermodynamic equilibrium, in that case, the ratio of the emissivity to the absorptivity is basically equal to each other. Okay, or we can say the ratio of emissivity to the absorptivity is equal to 1 here. So option number C is going to be the correct one here. Next part, when a mass is constrained to translation motion in the direction of x-axis, so that its change of position is described only by the value of the single quantity x here, it exhibits the. Okay, so now just see in this question, a mass is basically constrained constrained to have a motion, is basically constrained to have a motion only in the direction of x-axis. That means the mass is not able to rotate about any axis, the mass is not able to translate in the vertical axis, okay, and not it is allowed to translate in the z direction here. So we can say it can only move along the horizontal direction here, along the x direction here. So if you define the simple axis here, x, y, z, so here you can see the body is allowed to move only along the x direction here. That means it is only having the one motion, so we can say the degree of freedom of this system is the one here. It is going to be a single degree of freedom system here. And let us say if this body is allowed to rotate about any one axis, then the degree of freedom will become 2 here, okay. And if it is allowed to move in the y direction here, then it is going to have a 3 degree of freedoms here, because the degree of freedom is representing the independent number of motions which can be carried out by a body here. Next part, which of the following states that the pressure applied at one point to a confined fluid increases the pressure throughout the same amount? See, this statement is related to the Pascal law. Why so? Because the Pascal law states that whenever you are applying a pressure at one point in a confined fluid, it is equally transmitting in all the directions here, okay. So that will be the statement of the Pascal law here. So option number A is going to be the correct one here. Next part, which of the following generally has a highest head capacity? See, if I classify the turbine on the basis of the head requirement, so here you can see high head turbine are considered as a impulse turbine. Specifically, the Pelton turbine is considered as a high head turbine because it is a impulse turbine here, okay. So here we have a Pelton turbine which is a high head turbine. And when we talk about the medium head turbine, so medium head turbines are the Francis turbine here, okay. And when we talk about the low head turbine, the corresponding low head turbines are the Kaplan turbine as well as the propeller turbine. So always remember, in the case of a Pelton turbine, even though we have a high head requirement, but the corresponding discharge is very less. And when we talk about the medium head turbine, that is Francis turbine, the corresponding discharge is medium, or it will be more as compared to the Pelton wheel. And when we talk about the low head turbine, the corresponding discharge is very high, okay. Always remember that one part. So here the option number B is going to be the correct answer. Next part, rheopactive fluids are those whose apparent viscosity with time under a constant shear rate. Okay, so now just see one more thing. When we talk about the non-Newtonian fluid, in that case the fluids are classified on the basis of time independent and the time dependent here, okay. And specifically when we talk about the rheopactic fluids, these are considered as a time dependent fluid here, okay. So in this case the viscosity is basically a function of temperature here, it is depending upon time here, along with that it is depending upon du by dy here, okay. So now what is the meaning of apparent viscosity here? So if you see, in the case of a rheopactic fluid, the Newton law of viscosity can be written as tau naught plus mu du by dy to the power n here, okay. And where the value of the n is greater than 1 here. So if you rewrite this expression in this way, so here you can see I can rewrite this as mu du by dy to the power n minus 1 multiply by du by dy here. So here you can see I can write this expression as k du by dy here, okay. So here if I compare these two equations, I can say the value of the k is going to be equal to mu du by dy to the power n minus 1. So this parameter k, or this term mu du by dy to the power n minus 1, is known as the apparent viscosity. So the rheopactic fluid has the same characteristic which is having with the dilatant fluid, okay. And the property is that whenever you are increasing the constant shear state, whenever you are applying the higher shear state, the corresponding viscosity keep on increasing here, okay. That means the fluid become thicken here. So here I can say the option number A is going to be the correct answer. Next part, Dash law of thermodynamics is associated with the statement that it is impossible to reach the absolute zero temperature in a finite number of steps. That is a very simple question. This is the statement of a third law of thermodynamics, and the third law of thermodynamics is also known as the Fowler statement here. Okay, so Fowler statement is nothing but it is the third law of thermodynamics here. Next part, for any thermodynamic body, the sum of emissivity, reflectivity and transmittance is always. Okay, so now just see, it is asking you about the sum of the emissivity, reflectivity and the transmissivity. So just right now I have explained you the Kirchhoff law here. So according to the Kirchhoff law, the emissivity is nothing but it is equal to the absorptivity here. So here you can say the sum of the absorptivity, transmissivity as well as the reflectivity is equal to 1 here. So option number D is going to be the correct answer here. Okay. Next part, which of the following is an impulse type turbine? That's a very direct question here. Option number A is going to be the correct one. The Francis turbine, Kaplan turbine, both of them are the reaction turbine here. The Kaplan is a axial flow reaction turbine, Francis is a radial flow reaction turbine, Pelton wheel is a impulse turbine here, tangential flow impulse turbine. Now the next thing is the value of the the value of the lambda max multiplied by times from the Wien's law is given by, see in this case the value of the lambda max multiplied by temperature is always equal to constant here. The product of this lambda max and the temperature is always equal to constant, and this product is this product value, the constant value is basically equal to 2.898 into 10 to the power 3 meter Kelvin here. Okay, this is the standard value of the constant here, and this law is used to measure the temperature of those body which are at a very, very high temperature. So option number B is going to be the correct answer here in this case. Next part, when the damping factor is more than 1, that is a direct question. It is a overdamped system here. Next part, 1 mole of any substance contain dash elementary entities, and this number is known as Avogadro number. See, Avogadro numbers represent you the number of particles which are present in the 1 mole of a substance here. And how do we define the 1 mole of a substance here? Let us suppose if I talk about the 1 mole of oxygen here. Okay, if I ask you about what is the value of the 1 mole of oxygen, so here you can see 1 mole of oxygen consists of 32 gram of oxygen here. Okay, and how many number of particles and how many number of atoms or molecules are there? So there are around 6.022 into 10 to the power 23 number of particles here. Okay, so here the option number C is going to be the correct answer. Next part, the universal gas constant is defined as the Avogadro number times. Okay, so now just see one more thing. Basically the universal gas constant, which is having a value of 8.314 joule per mole per Kelvin, is basically considered as a product of Avogadro number, okay, multiplied by the Boltzmann constant here. Okay, so here if you see, just right now I have told you that the value of the Avogadro number is 6.022 into 10 to the power 23 here. Okay, and its unit is basically per mole here, the number of entities present in the per mole of a substance here. And if we talk about the Boltzmann constant, the value of the Boltzmann constant is around 1.38 multiplied by 10 to the power minus 23, which is having a unit of joule per Kelvin here. Okay, so if you multiply these two terms, you will get a final value of the universal gas constant here. So option number C is going to be the correct answer in this case. Next part, which law of thermodynamics is concerned with the entropy of a system as a temperature approaches absolute zero? Okay, so this is also a statement of the third law of thermodynamics here. Okay, we state that at the 0 Kelvin temperature you are going to have a zero entropy of a system, or we can say it is not possible to attain a temperature of 0 Kelvin in a finite number of operations here. Next part, the Reynolds number of 1800. The Reynolds number of 1800 is basically a laminar flow here, so option number D is also correct here in this case. Next part, a governor is said to be dashed if the speed of the engine fluctuates continuously. See, if the governor is basically in a condition where the speed of the engine is continuously fluctuating, okay, above and below the mean speed, at that point of time we can say the sensitivity of the governor is very, very high. Okay, and due to the higher sensitivity, the corresponding condition is known as the hunting here. So option number A is going to be the correct answer here in this case. Next part, At whirling speed, a rotating shaft typically exhibits the excessive dash vibrations here. So now just see here, if we have a shaft and if this shaft is rotating with some angular velocity omega, and if the angular velocity of the shaft will become equal to the natural frequency of the shaft, in that case what will happen, there will be a large amplitude of the transverse vibration there. Okay, and due to the very large amplitude of the transverse vibration, there may be a chance that the shaft will break here, okay, or it may fracture here. So here you can see at the whirling speed, a rotating shaft is exhibiting the transverse vibration here. Option number A is also correct here in this case. And also one more thing, the whirling speed of the shaft is known as the critical speed of the shaft. So whenever in the question, if it asks you to calculate the value of the whirling speed or a critical speed, you just have to calculate the value of the natural frequency. Okay, and this speed is also known as the whipping speed of a shaft here. This speed is also known as the whipping speed of a shaft here. So these three terms are analogous to each other. Next part, which of the following is an application of Bernoulli's equation? See, you find a direct application of Bernoulli's equation in the case of venturi meter, orifice meter, pitot tube, etc. So option number A is going to be the correct answer. Next part, the spring index of a helical spring, that is a very simple case here. The spring index of a helical spring is defined as the ratio of the spring diameter to the wire diameter here. So option number D is going to be the correct answer in this case. Next part, the effectiveness relationship of which of the following type of heat exchanger is given by the relation 1 minus exponential minus NTU 1 plus C divided by 1 plus C here. So just remember, this formula is basically valid for the parallel flow heat exchangers here. Okay, so option number C is going to be the correct answer of this question. So if you see very carefully, the exam pattern of the exam of the BDL is very simple here. You have a direct questions just right now. Okay, you just if you have a basic idea, if you have remember the basic formulas of each and every topic, you can easily solve that paper here. Okay, it is not taking too much time here. Along with that, it is the paper is not having any numerical questions here. All the questions are theoretical here. Okay, so the exam paper is going to be very easy here, for the BDL here. Next part, the axial deflection of a closed coil helical spring. How do you calculate the axial deflection? That is again a direct formula here. The formula is given by 8FD cube and divided by GD4. Okay, this formula can also be written as 8FKN divided by GD here, where K is known as the spring index, which is defined as the ratio of D by D here. Okay, just remember that one part also. Next part, the whirling speed of shaft is also known as the, just right now I have told you, it is also known as the critical speed, it is also known as the whipping speed here. And it is that speed where there will be a large amount of transverse vibration taking place, or like we can say the corresponding amplitude of the transverse vibration is going to be infinite, which may basically fracture the shaft here. So it is also known as the whipping speed here. Next part, for a condenser or a boiler, the ratio of C mean by C max, where again the C is representing the fluid capacity here. So if you see in the case of condenser or a boiler, one fluid is having a phase change here. So whenever there is a fluid phase change taking place in a heat exchanger, you always have to remember the value of the maximum heat capacity. The value of the maximum heat capacity can become equal to infinity here. Why so? Here you can see, let us suppose, here I am assuming, here we have a hot fluid which is maintained at a constant temperature, and correspondingly the lower fluid is gaining the temperature here. Okay, so here you can say the inlet temperature is going to be THI and the outlet temperature of hot fluid is going to be THE here. Okay, so if I calculate the value of the heat transfer, how much heat is being transferred here, so just I can directly write here Q is equal to MC THI minus THE here. It is going to be equal to MC TC2 minus TC1. So here you can see the temperature difference is basically 0 in the case of hot fluid, and the corresponding value of the heat capacity, that is the product of MC, will become equal to infinite here. Okay, So if the value of the C max is going to be infinity, so here the corresponding ratio will become equal to 0 here. Option number A is going to be the correct answer. Next part, pseudoplastic fluids are those in which the apparent viscosity. See, pseudoplastic fluids are those fluid which is considered as a non-Newtonian fluid, and it follows the Newton power law of viscosity, which is given by tau is equal to K du by dy to the power n here. And in the case of this, the value of the n is always less than 1 here. Okay, so if you rewrite the formula of the apparent viscosity, it will become this one here. So this term is known as the apparent viscosity here. Okay, so the characteristics of the pseudoplastic fluids are that whenever you are increasing the deformation rate, the corresponding viscosity decreases. That is why this fluid are also known as the shear thinning fluid here. These are considered as the shear thinning fluid. Okay, so option number C is going to be the correct answer here in this case. Next part, the emissivity of a gray body. See, gray body are those body which is having some value of the emissivity, and in this case the emissivity does not depend upon the wavelength here. It is always constant, it always remain constant with respect to wavelength. Okay, and its value always lies between the 0 to 1 here in the case of gray body, and in the case of black body its value is equal to 1 here. So option number A is going to be the correct answer. Next part, if in the superheated region the steam exists as a single phase region where the temperature and pressure are. See, when we talk about this superheated region, the corresponding steam exists as a single phase. Here we have a simple vapor phase, and there if you want to define the particular state of a steam, you have to define the independent temperature as well as the pressure of the system here. Okay, so we can say the temperature and pressure both are independent in the case of a single phase region, whether we are talking about the liquid state or whether we are talking about the vapor state. Okay, so this will be the option number A of this question here. So these are some of the question related to the BDL exam, and the other questions of the other part of this exam paper will be covered by the Rajiv sir. Okay, and now he will continue with the remaining questions here. Okay, so that is from my part. Okay, so let us start this second portion, which is going to be covered by the Rajiv sir.
Hello my dear friends, welcome to the YourPedia. That is we are going to discuss the Bharat Dynamic Limited questions. So first 44 question has been solved by the Benit sir. Now rest question I will deal here. Okay, so let's start with all these. So 45 question already you have did. Just a few seconds. All these you have discussed, right? So all these questions has been already solved and discussed. So let's start with the question number, I think 45. Okay, this is 35 question. And yes, my dear friends, as you have seen that most of the question is theoretical. So from that I have to start our discussion. I think that question has been done. Yeah, we shall start with the question. In part, the minimum amount of time required to complete the project, assuming everything goes exceptionally well, is termed as. So my dear friends, in case of PERT, basically this is known as project evaluation and review technique, and obviously it is a probabilistics model. So basically there are three time estimation. One is optimistic time, another one is we can say the most likely occur time, and pessimistic time. So here we can see that everything is goes according to the plan, right? Everything is going. That means whatever you have planned, everything is running like that. So obviously that is the time which will taken by the minimum amount of time that we can say. And this is known as what? Optimistic time. That means everything is going according to plan. Nothing is wrong according to plan. That type of time is known as what? Optimistic time estimation we can say. Pessimistic is also there, in which everything is goes opposite to your plan. Whatever you have planned, everything is going to be opposite to that. Like you haven't planned that there will be a strike of the labor. There can be the strike of the labor. there can be some another government policy change. So because all that if you are going to consider, then the project will complete. That is known as what pessimistic time, and most likely occur is that you are going to take average and then you are going to find the time. That is known as most likely occur time. So here required time to complete the project, and this is the minimum amount, because when you are going to plan, obviously you are planning such a way that time will take as minimum as possible, because if the time duration will increase, the cost of the project will also increase. Next question. Note recommended use sign bar measuring angle greater than. Sign bar, basically that is the part of metrology. You have seen the sign bar maximum angle that you can measure with the help of sign bar. That is how much, my dear friends? 45 degree. So it is not recommended to use sign bar angle if more than 45 degree. In such case, sign bar is not going to be used for measuring that one. So the correct answer will be what? 45 degree. Next question. That question has been, you can say, in every exam that type of question we can expect. That is from the material science. The question is that 1841 HSS high speed steel cutting tool generally contains. So what is the 18%? 18% is the tungsten, my dear friends. 4% is chromium and 1% is vanadium. That is a very basic question, has been asked in different exams. So try to remember that one. 1841, 18% is tungsten, 4% is chromium, and yes, 1% is vanadium is there. So correct answer will be what, my dear friends? Chennai is the right answer. C for Chennai is the right answer. Coming to the next question. Now, this is the next question. What type of feet indicated by H7P6? That question has been taken from the metrology, right? In the metrology, especially if talk about the feet and tolerances, right? So there are basically 18 grade is there. Out of these 18 grade, one is H and P. And one more thing, my dear friends, as you know, capital letters is basically going to for the indication of the dimension of the holes, or you can say the internal dimension, right? And if you talk about small letters, that basically going to indicate the shaft, or you can say the external dimension, right? So here the question is that which type of feet is there? You can say H. Capital H basically stands for the whole basic system. What do you mean by whole basic system? Here we can say whole basic system. Here we can say in the case of whole basic system, lower limit will be what, my difference? Will 0. So H7 and P6, H7, so this will be the whole, okay, and P6, P will be the above. So here we can say, and that let's say that is the base 0. So that is your hole, and that one is your hole, your shaft. This is your shaft. My dear friends, here we can say shaft is more than that of hole, right? But that is not much more. It is very less actual. So here we can see, my dear friends, that type of feet. Here shaft is more than that of hole. That type of feet is known as what, my dear friends? Interference feet. Suppose if shaft will be less than that of hole dimension, then it will be clearance feet. Then it can be clearance feet. But if their tolerance zone will coincide, if the tolerance zone of shaft and hole will coincide, then it is called as what? Transition feet, right? But here, as very clearly mentioned, you can say the shaft dimension is more than that of hole dimension. In such case, this is known as what? Interference feet. So try to remember all these. Interference, shaft will be higher dimension, clearance, hole will be higher dimension, or we can say in case of transition, the tolerance zone of shaft and hole is going to be coincide. Then it is called as what? Transition feet. So try to remember that one. Next question. Hooke's law states that stress produced to toughness, strain, resilience, a factor of safety. So Hooke's law states that stress is proportional to what, my dear friends? Strain, where up to proportional limit, or sometimes it is coming to the, especially we talk about mild strain. So proportional and elastic limit is very close to each other. So in general, it is applicable for, we can say, for within the elastic limit more precise, but in mild strain, since elastic and proportional elastic is very close, that's why. So Hooke's law basically states is proportional to what? Strain. So B is the right answer. Stress is proportional to strain up to what? Proportional limit. Next, if two objects collide and stick together after collision, this collision is characterized. Suppose this is one of the object, this is another object, okay, and let's assume this both are moving. This is, and now collision takes place. After collision, both are moving with the same velocity. So we can say in the collision, all the energy has been lost. Like no, it is moving with like that. That type of collision is known. There can be two types. One, they have collided, they start moving, and they have stopped. okay, all energy is going to be transferred, then it is called perfectly elastic collision. If both are moving with same velocity after collision, then this is called perfectly inelastic collision. So here we can say question collide and stick together after collision. That type of collision known as what? Perfectly inelastic collision. That is known as what, my dear friends? Perfectly inelastic. Where can be perfectly elastic? It will collide, going to give the all the, they are coming, going to give the all the energy to that object. Now it start moving. This is called as what? Perfectly elastic. So the correct answer here will be A for apple, because both are moving simultaneously and it is going to be stuck. Next, welding. Flush welding is a type of flash welding. This is riveting, gas welding, arc welding, or resistance welding. My dear friends, flash welding is a type of what? Resistance welding. In basically resistance welding as projection welding, seam welding, and we can say the projection welding. That all are going to be welded by the resistance when lap joint configuration is there. But if there is a butt joint configuration, then I am going to use the flash resistance welding. Flash resistance welding is going to be basically a weld when there is a what, which you can say the butt joint configuration. That means two objects each connected end by end. Then this is called what? Flash. This one here will be, another will be here, and after resistance, and then you are going to apply the pressure, then it is going to be connected. So that is known as a flash welding, or it is a type of resistance welding. Next, diamond has hardness value of the Moore scale. My difference, you know, diamond is the hardest material known till now, right? So the maximum, if you go through the Moores, so each have maximum value is 10, right? And you know, diamond have very close to that one. So we can say the correct answer will be C for Chennai. Diamond has the hardest value, and it can be the value, their numerical value will be 10 on the Morse circle. Morse scale, you can say, not circle, Morse scale, maximum value. So it will be the 10. Next, CHARP. Okay. Question is what? CHARP impact test use neither V notch or U notch, V notch, both V notch and U notch specimen or U notch. So CHARP is basically going to measure the impact test, right? In impact test, both you can measure V notch and U notch specimen, both can be measured. So correct answer is what? C for Chennai. Basically that question has been taken from the material science. One chapter is there, testing of material, there destructive testing and NDT, non-destructive testing. If you talk about CHARP, it comes under the destructive testing, and a lot of other testing like ultrasonic, all these coming under NDT, non-destructive testing. So here the correct answer is what, my dear friends? C for Chennai is the correct answer. Next question. When almost equal volume of oxygen and acetylene are mixed in oxyacetylene torch, so equal volume of oxygen and acetylene, both have equal volume, right? Then this is called what? Which flame? Then it will give the neutral flame. When oxidizing flame can be there, if the content of oxygen or volume of oxygen is more than that of acetylene, my dear friends, then it is called oxidizing flame. When it will be called is carburizing flame. So carburizing, when we can say the content of acetylene or volume of acetylene is more than that of the volume of the oxygen, we can say sometimes mole of the acetylene is more than that of mole of oxygen, then it is called carburizing flame. And carburizing reducing are very close, both are same. So the here in this, according to the question, the correct answer is what? C for Chennai, neutral flame. One more thing that you can keep in mind, mostly in case of oxyacetylene gas welding, I am going to use the neutral flame, because they are not going to be give any effect, not going to change the any property of the welding. But if you talk about oxidizing and carburizing, oxidizing, lot of oxygen is there, carburizing, they may increase the carbon percentage on the workpiece, so their property might be changed, right? So try to be, so very frequently or naturally you can say use the neutral flame. Next question. Necking occurs immediately after ... in stress strain curve for ductile material. So necking, so where it is going to be, my dear friends? Necking occurs immediately after. So necking is occur after the ultimate strain point. So correct answer is what? A. Necking is a tendency after that your body is going to be fracture under the loading. So necking is just start forming at the, you can say, ultimate strength point. That is the next question, my dear friends. Question is that in the measurement of surface roughness, again my dear friends, that question surface roughness you have to measure. That is the question of the metrology and inspection, or you can say more precise inspection part. The square root mean of the square of the ordinate of surface measured from a mean line. This is called is what? Both center line average value or root mean square value. You can say root mean square value we can use here. Basically here root mean RMS, I can say RMS, root mean square value is going to be that one. So the correct answer is what? D for Delhi is the right answer. Next question, which of the following utilize an exothermic chemical reaction supply the essential heat energy? In which welding? Arc welding, question is resistance welding, thermic welding or gas welding. So exothermic reaction, my dear friends. So in arc welding no reaction is there, resistance no, gas welding no. Here you can say in case of thermic welding. So in thermic welding what is going to be happen? There is a, you have one of the cylinder having here aluminum and aluminum Al2O3 form, and you can say iron oxide, right? One this is 1 and this is 3 ratio iron oxide, and after that this is filled. Now go to the site where you have to weld it. Now you have to put the magnesium rod there. You have to put the magnesium rod in that. As you are going to put the magnesium rod, the reaction start, exothermic reaction start. Due to that we will get a huge amount of heat, and approximate 2700 degrees Celsius you are going to get the temperature here. In this case your iron is coming in the molten state, and then you are going to pour on the material which is to be welded. So 2-3 point you have to be keep in mind in thermic welding. Ratio of aluminum and iron is 1:3, and this is what basically we can say in each exothermic reaction, in which you are going to get the heat which is basically takes place between the iron oxide and the aluminum powder. Aluminum powder will be there. So the correct answer is what, my dear friends? C for Chennai. Next, the grade of tolerance used in sand casting, my dear friends. As I told you, 18 grade is there. Every grade has some specification like IT1 to IT4, IT 5 to 8, basically in engineering application, more precision. So if you talk about sand casting, that is not much more precise, right? So if not much more precise, in such I am going to use the higher value, standard value. So it is coming out to be IT15 to IT16, right? I28 to IT11 if you talk, that is going to use for the engineering application. IT5 to IT7, more precise result where you have required. In such case this one is going to be used. So here answer will be what, my dear friends? A for apple is the right answer. Don't be confused about that. Next question. Oh, shit. That I have did. So a scleroscope generally used to determine of, this is what, raw bond hardness. So correct answer is what, my dear friends? Here it will be the A is the right answer. Now a fixture design in 3-to-1 principle indicate that major flat bottom resting plane of the work must be located on what? Fixed point. How many fixed point? So fixture 3-to-1 principle. Na? So in case of 3-to-1, 3 data is there. So basically here it will be what, my difference? Located on 3 fixed point. So correct answer will be the D for Delhi. It will located on the 3 fixed point. Again, import an event is the same as an activity represented by straight line, either be a start or completion of an activity represented by an arrow. So import, as I told you, this is project evaluation and review technique. So import, what is event? So either we can say like that, here or here, whatever, or might be like that. Okay. So that all are this one, this one, this one, all are is what, my difference? Event. So either a start or completion of activity. That we can say this is the completion of that activity, activity A, and that is the completion of starting of activity C. So either it can be a start or completion of activity. So correct answer will be what, my dear friends? C for Chennai is the right answer in case of PERT. Okay. Try to remember their full form, project evaluation review technique. That is also going to be asked various times. Okay, come to the next question. In rotation kinematics, the right hand rule can be used to determine. In rotation kinematics, basically that is the part of mechanics, the right hand rule can be used to both angular velocity and angular momentum. Both you can measure by using the right hand rule. So both angular velocity as well as angular momentum. Not only this only word is going to make it incorrect. When one dimensional perfectly elastic collision, which type of collision, my dear friends? Elastic collision takes place, momentum is always, as I told you, elastic collision, no energy is lost. Elastic means it is coming and going to collide and all the energy is going to be supplied to that object. So that is known as elastic collision. So elastic collision, no energy is lost. So we can say what? Momentum will be what, my dear friends? It will be always conserved. So we can say what? Fully conserved. So correct answer will be what? B. Partially no, fully no, fully lost no, partially only conserved no. The correct answer is what? It will be partially conserved. So correct answer is what, my dear friends? B for Bombo is the right answer. That is the same again question from the welding. Which of the following oxyacetylene welding flame type produce the hottest temperature, right? Which will produce the hottest temperature? So we can say, in case of oxidizing flame, what is happening, my dear friends? The content of oxygen is more. In fact, if 1 mole of acetylene, then it can be 1.2, 1.3 mole of oxygen. So oxygen is more. So there will be a proper burning of the acetylene. If the proper burning will take place, my dear friends, the heat generation will be the maximum. So if it is going to ask, so maximum temperature approximate 3400 degrees Celsius, sometimes more than that, going to get in the oxidizing flame. If you talk about minimum temperature, so it can be from the carburizing flame, because in the carburizing flame, the oxygen concentration or mole of the oxygen or volume of the oxygen is less than that of the supplied acetylene. So not a proper burning is takes place. If not proper burning of the carbon will takes place, it will be unburned. So not you are going to get the sufficient amount of heat, or you can say the maximum heat. So in fact, in case of carburizing flame, I am going to get the least amount of heat. If you talk about neutral flame, it will be in between the oxidizing and carburizing flame. So here hottest flame talking, so it can be what? Oxidizing flame, my dear friends. If you talk the least hottest, then it will be carburizing. Next, in part an activity generally represented by square, represented by circle, one which can consume time. My dear friends, activity is something which is used to consume the time. Or sometimes you are going to say the resources. Resources can be time, money, manpower, that all are resources. So in part, if you talk about activity, obviously it will take time, money, so that is consume resources in one word we can say. So obviously it will take the consume the time, not even time, some resources they will also take, manpower you have to be give that, so should be resources, but okay, time is also resources. So I will go with the option C, represented by square, no. So the correct answer is what, my dear friends? C for Chennai is the right answer. Next, in ASA stands for American Standard Association. ASA stands for American Standard Association. Of specifying cutting tool signature, the back rake angle is the position among the numbers second, third, fourth and fifth. My dear friends, what is their position? This is alpha B, alpha S, after that gamma E, gamma S, after that CE, CS, and after that R. Back rake angle, side rake angle, end relief angle, side relief angle, and cutting edge angle. This is side cutting edge angle, that side cutting edge angle, and last one is what? Notch radius. So the question is that back rake angle. Which rake angle? Back rake angle, alpha B. So it will be at the first position. What position, my dear friends? Back rake angle will be the first position. Try to remember that in that sequence. First back rake angle, then side rake angle, after that cutting relief end angle, and then side relief angle, after that end cutting edge angle, then side cutting edge angle, then nose radius. So here D is the right answer. First you talk about the back rake angle, then it will be the first position. That is the next question. If the coefficient of restitution is equal to 1, the collision is characterized as, okay, if the coefficient of restitution is 1, then it is called as what? Perfectly elastic collision. then it will be called is what? Perfectly elastic collision. Then answer will be D for Delhi. D for Delhi is the correct answer. So you can say how much student is going to be texting right now. In my here tab here, WhatsApp is on in the background. So students are going to be continuously putting the message in the group. That's why. So D is the right answer. Next, my dear friends, here basically this is the torque equation. So if you have remember, T by J, G theta by L, and what? Tau by R. So here tau shear stress, S is here for the shear stress. So T upon G, G theta upon L. So yes, my dear friends, A is the itself right answer. Here usually I am going to use the tau, but here instead of tau they are going to use the S, shear stress at the outer fiber. So simply we will get the option A. That is just a torsion equation that you have to be keep in remember. Have you anyone have remembered the bending equation? So please write down the bending equation in the comment. Next question. In the stress strain curve for ductile material, the point which corresponds to maximum value of stress, this is known as maximum value is known as what, my difference? Ultimate strength. Okay. Strain curve, the ductile material, the point which corresponds to maximum value of stress is what? Ultimate strength is the right answer. Next, which are the following the dimension formula of acceleration? What is the unit of acceleration? Meter per second squared. Meter per second squared, no? So meter, we can say L T k power 2. So simply we can say M k power 0, L k power 1, T k power minus 2. See this? M k power 0, M, okay, here, or we can say L k power 1 or T k power minus 2. So here you are going to get the answer is what? D for Bombay is the right answer. Okay. Whenever you are going, it is going to ask to calculate dimension. Try to convert in the primary physical quantity form like mass, length, and time. Whatever is there, try to convert in the MLT form. Then we will get the answer. Next, the working temperature generally below the 450. If the working temperature is below 450, this is known as what? Soldering. Soldering. Okay, a student is going to be confused in soldering and brazing. Soldering and brazing. So just by one, my dear friends, see brazing B4 there, na? So B4 just try to be bigger. Soldering S is there, shorter. Okay. So if the temperature is working temperature, if less than 450, it will be called as soldering. If more than means bigger than 450, it will be called as brazing. So by this keyword, I know most of the student is going to be confused in that one. Even in the exam, you know, yes, one have less than 450, otherwise have more than 450. But they are going to be start confusing which one is more than 450, which one is less than. That's why I used to say the student soldering stand for S for solder. So temperature less than 450, short than 450 will be considered soldering. Soldering and more than or bigger than 450 is known as what? Brazing. So here correct answer will be, my dear friends, since it is temperature below na 450. So by this try to be remember. Okay. EDM is a type of non-traditional machining. Electro-discharge machining is a non-traditional machining, or you can say unconventional machining. Here it is going to use the what? Thermal energy. Which type of energy it is going to use? Thermal energy it is going to use. So correct answer will be, my dear friends, C for Chennai is the correct answer, thermal energy. Ultrasonic machining, that again from the NTM, non-conventional machining, unconventional machining, type of non-traditional machining. Ultrasound, no, my dear friends. So that is the mechanical. Why? Here ultrasound is what do you mean by ultrasound? The sound having frequency more than 20 hertz, or 20 kilohertz, or we can say 20,000 hertz. Then this is called what? Ultrasound. And here mechanical energy is going to be used. The second number of ORS system specifying the cutting tool signature gives the second number of in ORS. So second number is give basically orthogonal rake angle. If we talk about this one, so it gives the orthogonal rake angle. Now the grade of tolerance indicate I21 to IT4 application in production of gauge and plug gauge. Yes, more precise is there. So plug gauge and gauge. If what is the function of plug gauge or snap gauge is there, so we can say basically snap gauge, plug gauge is going to use to measure going to find the is it shaft or hole is given range or not, or we can say it is going to measure. Basically, you can measure by two things, either by variable or either by attributes. Variable means suppose I have 10 rupees, you have 5 rupees. So we can say, sir, Rajiv sir have 5 rupees more than that, more than me. That means that is called variable. Now, suppose two person is there, one is more beautiful, other one is less. So you can say she is more beautiful. So what is the value of beautiful? So it is called attributes, right? It is not going to give any numerical value. If you get the numerical value, it is simply known as what we can say variable. Otherwise, if you are going to measure anything, suppose one is this color black is and another one is this black. So which one is more black? So sir, this one is more black. So this is like a what attributes. Next, Taylor tool life equation V to power n equal to constant is represented what, where V represent the cutting speed. That is a very frequently used. So what this is going to be indicate the cutting speed. That the actual load divided by the current cross section area rather than the initial, this is known as what, my difference, true stress. You know, current cross sectional area. So this is called is what, true stress. You know what is true stress? Let's see. Suppose that one, that is the cross sectional area you are going to apply. So what you can say, sir, force upon area, this area pi by 4 d square, that diameter. But you know, as you are going to increase the load, their shape will also change, no? Their shape will change. No? So if you are going to use that d2, let's say. So if you are going to stress f upon pi by 4 d2 square, then this will be called is what, true stress. And this is called is what, engineering stress. In which you are going to use the initial diameter only, but here as load increasing, diameter control is changing. So at that load you are going to calculate the stress, that which is called is what, true stress. Okay, the Mohs scale is used to check obviously identical hardness, indentation hardness, rebound. Mohs is going to be measure the scratch hardness. So correct answer will be what, my difference, C4 Chennai. Scratch hardness. Diamond have highest. That is the next question. If the moment of resultant force on a particle is zero during the interval of time, then its angular momentum will be remains unchanged. You know, if moment of resultant force of a particle is zero during the interval of time, then it will be called, it will be remains constant. It will not going to be changed. Which of the following grade of slip gauge is used to mainly the inspection department to check its accuracy of other grade? So I am going to use the grade 0 because huge is required now. That's why I am going to use the 0 grade. Next, a perfectly elastic collision one dimensional is defined as one in which kinetic energy is not constant, there is no net loss of kinetic energy. Perfectly elastic collision one dimension. So perfectly elastic collision, so obviously there will be no loss of any kinetic energy. So there is no net loss in the kinetic energy because all will get changed. Next question. In the stress strain curve for ductile steel, plastic deformation first observed after the plastic deformation. Obviously, we can say ultimate fracture. Yes, it will be the yield point. After yield point, we are getting the plastic deformation. right? Or sometimes it is the minimum amount of load required to start the plastic deformation is also known as yield point. So try to remember that one. Next question. The expansion of CPM in project management. Okay, what do you mean by this one? So crisis path measurement, continuum path measurement, crisis path, no. This is CPM, critical path method. CPM extend for the critical path method. So the correct answer is what, my difference? D for Delhi is the right answer. CPM exists for critical path method. Next question. When angle of contact of the bearing with the journal is 360, then the bearing is termed as. When the angle of contact of the bearing is journal 360, then this bearing known as full journal bearing. What do you mean by journal? So journal is that part. Suppose this is your shaft, okay, and that much part is within the bearing. That much part is within the bearing. So the part of the shaft which is inside the bearing, that is known as journal. And if the contact is 360 degree, then it is called your full journal bearing. Try to remember, right? Rockwell scale generally used for the measurement of row scratch hardness. Scratch is going to be Morse. So dynamic indentation hardness. So Rockwell is going to measure the indentation hardness. So D for Delhi is the right answer. Indentation hardness. Scratch hardness by which one? Morse. Right now we have seen. Next. Self-locking of a cylindrical work better achieved in fixture designed by 2 locator pins, 4 locator pins, V block, or we can say 3 locator pins. So what will be answer, my difference? You have to get the self-lock, na? So self-lock V block is one of the very effective, having self-lock tendency. So this question from the machine design. Next question. Generally in the whole basic system, basically that is going to be indicated by the capture lab. Upper deviation is 0. Upper deviation of the shaft is 0. Lower deviation of the hole is 0. Yes, lower deviation of the hole is 0. So correct answer is what, my difference? 0. And D is the right answer. Generally whole basic system, lower deviation of the hole will be 0. Lower deviation is what do you mean by? Suppose I have just give the, this is one of the hole having dimension 100. Lower deviation plus is 0.2, minus is 0.00. So that is your 100. Okay, that is your 100, and that is the upper limit of hole. This is upper limit of hole, which is equal to 100.2. But here you can see the lower limit is 0, or in fact you can say fundamental deviation is also 0. Because fundamental deviation that which is close to the baseline. This is your basic line, right? This is. So here we can say simply, sir, lower deviation is what? 0. So D is the right answer. In shaft basis system, upper dimension will be 0. A small h exists for the shaft basis system where upper deviation will be 0. H7K6. What is this? H7K6. H7 whole basis system, K6. So here it is comes under the transition fit. It comes under the transition fit. Next, in one dimensional inelastic collision, momentum is inelastic collision in one dimension, inelastic collision, complete loss converted in another form, partially. It will be conserved, right? It will be conserved. The term pessimistic time estimated PERT means the time required to complete the task, assuming everything goes wrong. So this is known as what? That will be the maximum time. As in the starting of the session, I have told you about the PERT. So it will be what? Maximum time. So my dear friends, what analysis we can see? Most of the question from the industrial production is that question, and that all are objective or one-liner question. So if you are make command on all that type of question, obviously you will be feel yourself in the very safe zone, especially if we talk about Bharat Dynamic Limited. Not a difficult type of question going to ask, basic is going to be checked. So you have to plan accordingly. Don't go through the much more numericals. Don't waste your time to solve that type of much more numericals. Go through the basics. What is the function? That only basic things is going to be asked. And you have seen in the engineering mechanics, collision chapter is one of the important topic for that one, because most of the question has been taken from the collision in mechanics. So that all are important, and you can join my batch, my dear friends. That batch is running in this you are that type of question which is expected in BDL, so that you will feel yourself very safe zone. I will discuss through the different types of question, whatever level is required. I will try to keep that level in our class. So you can join that through my panel, and hopefully we will meet with you in that session. Okay. Thank you, my dear friends. Thank you, and yes, good luck.